I like to do this one because I'm familiar with it.
So is there like an equation in there?
For this right here, it basically is your output force over your input force. All right? So what we're trying to do is how do we increase our output force given a small input force? So a traveling block basically is you have these pulleys like this, and I'll show you a picture of this in a second. So you have all these pulleys connected by a single shaft, and below it you have another set of pulleys that are connected by a single shaft. And the weight is coming off of this one here. This is your weight. And then what you do is you anchor your cable here, and you have a configuration that looks like this. You go over this pulley, come around, come like this, and go like this, come around like that. And you have F here, okay? So in this one here, you have F equals 1 over 2n times W. Here, n equals 3. So in this case here, your mechanical advantage would be 6. Okay. So let me show you a picture of what this is.
So n is the number of pulleys on the weight.
Yes.
Can you say that again?
N is the number of pulleys on the weight side of it, okay? And 1 over 2n times W, that implies if we have n equal to 3, your mechanical advantage equals 6. All right? So in other words, you take this force here, if you're applying a 1 pound force here, you can pick up something that's 6 times its weight, or 6 times 6 pounds of force. All right. Now this is used. Do you know where this is used a lot? So on these oil rigs, this is called the traveling block right here. So the traveling block goes up to, is tied with these cables to what they call the crown block. All right? The reason I know this is because my first job out of undergrad was working in oil fields, out on the rigs. So we spent a lot of time looking at these traveling blocks. And how it works is you have this motor and you have the cable on a drum, and you have multiple pulleys on the crown block and also the traveling block. And it's anchored here, all right? And what happens is this thing here is spinning like crazy. And this thing here is just barely moving, if there's a lot of weight, okay? It all depends on the weight. But what happens, the reason why they have this storage reel down here, because after certain, what they call trips into the hole, trips out of the hole, that cable starts to fray. You don't want that cable to break, okay? So what they do is after so many trips in and trips out, they will go ahead and strip away the cable. and then they'll spool new cable here and loop it through and then tie it to the drum. And then the drum right here eventually is full of cable that's not usable again, and they recycle that. All right, so that's how this thing works. But you get tremendous amount of, I mean, we're talking thousands and thousands of pounds of force that these things can pull. All right, because these drill stems are quite heavy. This one here, that picture right there is from Oklahoma, 31,000 feet. Now the deepest well that I was on, it's still the deepest well in Texas, is, I wrote it down somewhere. The Hunt Surf Ranch in Pecos County. Anyone from Texas here? In Pecos County, it's out in West Texas.
Is that
20
Midlands, Odessa?
That's where I live. We call it Midlands Slodetha. But anyway, it was, there's a bumper sticker that said, you know, be nice to people, say your prayers, because if you don't, when you die, you'll go straight to Midland. So, but that's where I lived, out in Midland. And so this Pecos County rig that I was on, 29,670 feet deep. If you do the math, that's 5.6 miles deep. So it took a long time to trip in and trip out of that hole with these troubling waters. All right, so that's kind of like the intro to mechanical advantage. But what we're going to do is we're going to use mechanisms to achieve mechanical advantage. And a great mechanism that illustrates that is your homework problem, which is the vice grip. A vice grip is a 4-bar linkage that you can actually get great mechanical advantage out of it, as you know, because you can lock things in and tighten down on things. So let me show you how you can look at linkages in order to create mechanical